China's eagerness to use genetic enhancement technology has led some to suggest the deeply divisive issue could cause a new kind of Cold War conflict. Welcome to the brave new world of gene editing. An international team of scientists in the United States have safely repaired a gene mutation that causes a heritable heart defect in human embryos, sparking debate about the new frontier of genetic engineering. The first of its kind research, which was spearheaded by the Oregon Health and Science University and published last week in the journal Nature, could one day help families affected by inherited diseases. I, for one, believe, and this paper supports, the view that ultimately, gene editing of human embryos can be made safe. Then the question truly becomes if we can do it, should we do it, said Dr. George Daly, the dean of Harvard Medical School. One major fear is that this kind of human embryo modification could give rise to designer babies, allowing parents to pay for desirable traits they want in their kids. I think gene editing can be used to help people who are sick, Marcy Darnofsky, director of the Center for Genetics and Society, said, but the idea of using it on the front end to engineer a future generation, we need to draw a bright line there. She insisted that current embryo screening technology, done routinely at in vitro fertilization clinics across America, already helps parents avoid passing on genetic diseases to their kids. If you're worried about passing on some inherited disease, you can already do that without mucking around with your child's genes, she said. David King, of the Human Genetics Alert, a York-based organization, said governments need to wake up and pass an immediate global ban on creating cloned or GM genetically modified babies before it is too late. If irresponsible scientists are not stopped, the world may soon be presented with a fait accompli of the first GM baby, he said. In this photo provided by Oregon Health Science University, taken through a microscope, human embryos grow in a laboratory for a few days after researchers used gene editing technology to successfully repair a heart disease-causing genetic mutation. Source: Abhijit Shukrat-Mitalipov, an embryologist at OHSU who led the gene editing experiment, said the research was about correcting genes that cause diseases, not altering them. Really, we didn't edit anything. Neither did we modify anything, Mitalipov said. Our program is toward correcting mutant genes. The researchers used a gene editing tool called CRISPR-Cas9, which acts like a pair of molecular scissors, to target a mutation that causes hypertrophic cardiomyopathy, a disease that weakens the heart and has led to the sudden deaths of many apparently healthy young athletes. They then injected sperm from a donor with the heart disease, which affects 1 in 500 people worldwide, into eggs from 12 healthy patients, along with the genetic scissors to snip out the mutated gene. Scientists were surprised to discover the embryos then repaired themselves, taking a healthy copy of the gene from the egg as its cells began to multiply. The embryos are really looking for the blueprint, Mitalipov said. We're finding embryos will repair themselves if you have another healthy copy. All told, the experiment was successful in 42 of the 58 embryos used, about 72% of the time. Mitalipov now hopes the strategy could one day be used to prevent a slew of heritable diseases caused by gene mutations, which include Huntington's disease and cystic fibrosis. Every generation on would carry this repair because we've removed the disease-causing gene variant from that family's lineage, he said. By using this technique, it's possible to reduce the burden of this heritable disease on the family and eventually the human population. There have been previous attempts to edit embryos in China, but those experiments were marred by a problem called mosaicism, which means some cells in the embryo still carry the mutation. Mitalipov said they solved that problem by intervening before fertilization. Everybody was injecting too late, he said. But China's eagerness to use CRISPR technology has heightened concerns about designer babies and prompted some to suggest the deeply divisive issue of genetic enhancement could cause a new kind of Cold War conflict. Shukrat-Mitalipov left talks with research assistant Haley Darby in the lab. Mr. Mitalipov led a research team that, for the first time, used gene editing to repair a disease-causing mutation in human embryos. Picture Christina Wensgraf, Oregon Health Science University. Source: App. Scientists are still a long way off from taking their gene editing experiments out of the lab and using them on pregnant women. There are safety concerns, of course, but also regulatory roadblocks in the U.S. The National Institutes of Health doesn't fund research involving embryos, and Congress doesn't allow the FDA to consider any experiments that involve genetically modified human embryos. This experiment was financed by OHSU, the Institute for Basic Science in South Korea, and others. Particularly controversial is the idea of germline editing, making precise genetic changes that can pass on to future generations. Advances in technology have given us an elegant new way of carrying out genome editing, but the strong arguments against engaging in this activity remain, the NIH said in 2015. These include the serious and unquantifiable safety issues, ethical issues presented by altering the germline in a way that affects the next generation without their consent, and a current lack of compelling medical applications justifying the use of CRISPR-Cas9 in embryos. But more recently, the National Academies of Sciences, Engineering and Medicine took a softer approach, advising caution but not prohibiting germline editing. We say proceed with all due caution, but we don't prohibit germline after considerable discussion and debate, said Richard Hines, an MIT biologist who chaired the review. We're talking only about fixing diseases, Medalipov said. Regulators should start giving more guidance on what's permissible, especially since some scientists may resort to conducting their experiments in areas that don't have regulations. This technology will be shifted to unregulated areas, which shouldn't be happening, he told The Washington Post. Medalipov added that they could be interested in continuing their work in other countries, like the United Kingdom, NPR reported. Medical ethicist Arthur Kaplan said the technology is still at embryonic stages in terms of developing legal guidelines. Who should own genetics engineering techniques, and what, if any, requirements will they have to make the taxpayer-funded research that made this possible available and accessible at affordable prices, said Kaplan, founder of the Division of Medical Ethics at NYU School of Medicine. This article originally appeared on the New York Post.